There we go. How about that? My name is Taylor Brown. I'm a lead program manager in the Windows team, and I'm joined by my co-presenters.
I'm Scott Hunter. I'm the Director of Program Management on the .NET platform at Microsoft.
And I'm Adam Braden, a program manager in the Windows Developer Platform team.
Yeah. So we're here to talk to you today about a journey that we're all starting together around modernizing .NET applications. And really our goal as we kind of go through this is to talk about how we can start to modernize these applications without having to rewrite them from scratch, without having to throw everything out and start all over again, right? So I've been using this kind of frame for the last year or so, and I think it actually resonates really well. It certainly does for me, and it seems to for a lot of people. As a developer, we spend a lot of time debugging an existing app that we've got in production. We spend a lot of time fixing the existing apps that we have in production. We spend a lot of time trying to add features to apps that we have in production. And we spend way too much time fixing the features that someone else tried to add to the app in production. That resonate? Yeah? And then maybe if we have a little bit of time, we actually get to try to build something new. And maybe if we're really lucky, we actually get to build something new with some new technology that you've heard at some great conference somewhere, right? On the same time, for our IT pros and our admins out there, they spend a ton of their time doing the same sort of things, maintaining that existing app, redeploying it when there's a problem, diagnosing an issue and getting the right dev team involved to go figure it out, troubleshooting the issues that come when someone tries to add a feature to the app. And then if they actually get some time, maybe they get to think about what it's going to take to actually deploy a new application that's in production. And what I actually find more and more is that they don't get that time. So the dev team comes running in the door with, all right, we got a new app where you need to deploy it today. Like there's no planning, there's no time to think through how are we going to put this into the cloud? Are we going to make this geo-redundant? Are we going to, what's the backup strategy? Because we're so far behind from doing the first set of things. Okay. So how do we fix this problem? How do we get out of this cycle? Well, we can't just throw out every old app that we have. I mean, we'd love to, but I'd love to show you our time and absence reporting tool for Microsoft. This thing is like circa 2003, but it still works. And we can't just get rid of it until we have a replacement for it. We really can't get away with not adding new features to the apps. So if someone comes in and they need to have a way to reconcile this, vacation, or a new policy comes in that we're going to add bereavement time or something, you have to be able to deal with it. We obviously can't just stop maintaining the old app. They're critical. They're critical for our systems. What we can do is make it a lot easier. We can make it a lot easier to maintain these applications, and by doing that, we can gain time. And we can start to use these new tools and processes with our existing applications. And that's actually what we're going to spend a lot of the time today talking about, is that process, right? So I lifted this slide from Jason Zander's keynote talking about legacy to cloud ready to microservices, a pattern of taking an existing application, moving it into a container so that we can gain some agility around it, integrating that with modern methodologies like DevOps and Agile and all these buzzwords, right? Now we can start to move that to modern infrastructure like the cloud when we're ready to, and we can start to redevelop it into modern microservice patterns, right? And we don't have to do all of that by throwing everything away. We can do it as we add. So as we go through today's session, we're actually going to use a sample application that some of the folks on our team built for us to talk about this pattern. And that app has a very traditional pattern. I suspect a lot of you have this. If you've got an app like this in your environment, I'd love to see raise of hands. Yeah? WinForms front end, WCF or some middle tier, and some sort of database in the back end, right? Not very portable, pretty hard to move to the cloud. By itself, you've got all sorts of challenges with latency and how does the middle tier communicate with the back end. So we're going to walk through a methodology where we're going to package up the front end. We're going to make that redeployable. By making it redeployable, we can now make some changes to that front end. So we can do something like switch it over to pointing to a container, right? We can start to add little bits of features to that front end. Then we can add like a new .NET Core API alongside. So now we've actually built our microservice. We've built our first little addition to that middle tier, probably in a very long time, but using a modern technology. And then we'll talk about how we can actually start to move the database around and gain some agility out of it. Okay? So that's kind of the pattern of the talk we're going to go through today. And hopefully our end state is that we can get to a point where we've got an app that still looks very similar to what it had, but is now more modern and extensible. Okay? So with that, we'll start on our front end.
All right. Thank you, Taylor. So what do we mean about modernizing the front end? I'm going to talk to you about two key problems that you currently face. First one is a little bit more tactical, specific to WinForms apps. And then the second one is a bit more broad-reaching in terms of how you address deployment problems in your enterprise today. So the first problem we're talking about is Windows Forms and high DPI support. Show of hands, I guess, how many of you still have Windows Forms apps in use in your enterprise today? Yeah, most of you. That's great. How many of you bought new laptops or large monitors in the last year or two? Yeah, most of you. How many of you have gotten an email from, say, your CEO or your VP of sales saying that that application looks like crap on their new laptop or is even not functional because the display is so bad? There's a handful, yeah? So I'm going to tell you how .NET Framework and Windows Forms fixes that in .NET 4.7. So first, let me switch over and show you the example of how bad it is. Here is our example project called eShop. This is a simple Windows Forms application on the front end and a WCF service in the middle tier, and it talks to the SQL Server backend. On the form, you can see it's just a simple Windows Forms app with a data grid that will display the rows of our data to help us manage the inventory for our shopping site. And on the Inventory tab, it also has some functionalities that somebody in-house would do to help manage the inventory that we have, searching for stock availability, adding stock, and shipment dates. So this device that I'm currently on is a Surface Book, has a big, beautiful, high DPI display, and it's currently running at 225% scale factor. Let's see what happens when I run this app currently as is. Visual Studio's got to compile and load. And that is not what I was expecting to see on this display. From here, you can tell that on this high DPI display that the form is cut off at the bottom. I can't really see anything in the grid. And that's because the images, by default, are scaled to 225%, and so it takes up all the space. Additionally, you'll notice that the combo box is cut off at the bottom of this. And then when I go to my Inventory tab, I can hardly see any of the content that I had. The buttons that had an Add Shipment button, the text is cut off. And so what you see here is a lot of the content is scaled too large, but the frame of the controls are often scaled too small. And so this app is really not functional on this high DPI display. Good news, there's two things you can do to fix this, or two steps to fix this, and they don't involve changing your code. They just involve configuration settings. The first one is changing the project properties to target .NET 4.7. So if I right-click on the project, my WinForms project, and bring it up, you'll see that my target framework is 4.6. By simply changing it to 4.7, that now enables the platform to have support for high DPI. VS has to close the project and reopen it because I've changed the references to 4.7. And now the second step is in my app.config file. There's a new setting called DPI awareness. And this is specific in the Windows Forms sections of the settings. If I simply uncomment this and save, now I've given the platform the capabilities it needs to detect high DPI and fix this for your Windows Forms applications. Let's see what happens when I press F5 and run it again.
Oh, function keys.
Function lock. All right. So I'll click the Start button instead. And so now the app is back into a more functional state. You can see I've got multiple lines, so I have back at my high data density display that I'd expect on a desktop application. The controls don't have their borders cut off. The scroll bars are now appearing properly on the form itself, and I can access everything with the inventory management. If I choose an item, it talks back to the server, just confirming that I'm actually talking live to the server to see the results. And so what we've done there is we've enabled a lot at the platform level to fix this via these settings. There's also some options that are enabled at the developer level. So first, with the improved .NET Framework 4.7, your standard controls plus your more complicated controls now have this support. And secondly, for any custom rendering that you're doing in your own controls, we now have the capabilities in the platform for you to call. Oops, next slide. Next build out. You now have the capabilities to call to check if the DPI has changed and also to get the DPI settings so you can convert from your logical pixels to your device units.
I want to add one more thing. All the WinForm controls don't support high DPI at this point, but every release that's coming
is getting better.
Is getting better and better. You'll see us continue to invest in making more and more of the WinForm controls have full support. And we have blogs that actually, and docs that actually talk about which ones have full support today.
Yeah.
And as we go throughout this whole thing, our email addresses are at the front of the slides. We'll make sure that we show those again. If you have feedback, if you have areas that are painful for you, hey, this control really hurts us, we really need it, please let us know. It is comments from you that enable us to go to our bosses and say, this is the work that we need to prioritize for this release to get it in so that this customer can have a good experience.
Right.
So now you've made an update to this app, and you need to deploy this update so it looks good on your CEO's laptop. But before you go to rebuild your Click Once installer or MSI installer, let me tell you about a better way.
Actually, I'm just curious, who here uses MSI installers for your apps?
Yeah.
How about
Click once.
Yeah.
Half and half, or 2/3, 1/3. And so, those technologies have been around forever, and it's essentially how you deploy applications to your computer. But before I go into some details, I just want a quick show of hands. Who has home computers? Right? Everyone? Yes. And how many of you install apps from the web on your home computer? Most of you? And how many of you have a moment of hesitation before you click yes on giving that application installer admin privileges to write all over your computer? Yeah, I do. Usually I try to internalize, it's coming from a decent, reputable site, or the company seems well known. But my kids don't. My kid installs all kinds of game mods left and right, and I tend to get malware a lot. And so a lot of times you click and hope for the best. We want to remove that feeling from deployment. The other problem after you've installed it is you're done with that application, and you need to uninstall it. There's a problem with uninstalling. Oftentimes, the installers today leave behind key points, whether it's files in the desktop shortcuts, files in the file system, or registry keys. And your system just has a lot of cruft left behind. And it never feels like that app is truly removed. In the enterprise space, you guys usually deal with this by having various install scripts to make sure the app is deployed in the proper location. And you also have various uninstall scripts to make sure the app is truly cleaned up. And those apps are usually deployed, or those scripts are usually deployed through group policy. I don't know about you, but I don't really enjoy that if that would be my day job, to be able to manage and maintain those scripts. So perhaps there's a better way. Let me go through the desktop bridge. So with the deployment pipeline in the Universal Windows platform, we brought that pipeline to your Win32 and .NET applications via the desktop bridge. One way for you guys to think of the desktop bridge is really a lightweight container for your application. And by a container, I mean it's redirecting the file system and registry access for that application and making it app-specific so that the app does not impact the rest of the system. And those rights are localized to that app, which makes it very easy to install and uninstall.
So I know I've talked to a few of you even here today. How many people have said, I want Docker for desktop apps? I know, yeah. This is basically Docker for desktop apps. In fact, when he's talking about the redirection of the file system and registry, it's using the exact same code that we built for server containers, the exact same code that we use for Docker. Basically, what we're doing is we're running effectively a privileged container. We're giving it the file system and registry redirection, but we're allowing it to talk to all the local system processes. So you can still do things like copy and paste across different apps that are in their own container, right? So it gives us the feeling of an integrated app experience, but it gives us that redeployment experience, that cleanup and remove experience of a container.
So there's really two scenarios you have when you want to bring an app to the desktop bridge. The first one that I'll go over first is the scenario where you do not have the source to the application. All you have is an installer, an MSI file, or something like that. And to bring that to the desktop bridge, you have to run a tool called the Desktop App Converter. Is that number 8? Yes. So that Desktop App Converter you can download in the store. And so I've got it shown up here in the store. I already have it installed. It takes just a moment to install. And there's also a base image that the container runs in for conversion, which you'll also have to download and install. I've already got that set up here. And what I want to do is show you an example of converting a very simple app called Notepad++. Anybody familiar with Notepad++? Yes, okay. What I've got here is just the installer exe file in here. And in this folder, I have a batch file, which is all of the commands to, or all the parameters to the desktop app converter, showing it how to convert. Since this step takes just a couple minutes, I'll go ahead and run it first, and then show you what the batch file does. So in Notepad here, you can see I'm just calling the desktop app converter. And then the next two parameters are the installer itself and the installer arguments for silent mode. Since there is no UI, the installer must install silently. You need to be able to pass those flags. Next is the destination of where to put the package output. And then the third and fourth and fifth parameters are all about the package identity. That's one of the key things about applications on the desktop bridge is you have to give them identity so the OS can manage them.
Can I borrow you for 1 second?
Sure.
Make the font a little bit bigger here, guys.
Oh,
I'll let you do it.
okay.
Make the font bigger. There you go. That's good. Perfect.
All right. Apologies for that. Thank you, Scott. We've talked about identity there. That's the package name, the name of my app. So that's what's going to show up in the start menu. The publisher. This is usually tied to the cert that I'm going to sign the app with. And then, of course, there's the version and architecture of the package. The last three parameters are just how to build the application, telling the converter to build an Apex package, sign it, and then also provide verbose output. So here we'll see that the converter completed. What the converter actually did in this step was it started a container with no UI. It copied the installer to the container, ran the silent flags on the installer, kept track of all the changes to the system, and then exported those changes. After it was exported, the converter processed those changes to filter out all the system noise. and then created a package for us. Let me take a quick look and show you what the output looks like. So if I go in the output folder, I'll see Notepad++, and I'll see my AppX file, which is my package, my certificates, and then my logs folder, which is all the logs for the desktop app converter, so you can see exactly what it did and what it processed, and then the package files. I'll go over that in 1 second. An AppX file is really just a manifest which declares everything that the app, all the app's capabilities, plus its identity, and all the binaries and content files packaged up all in a zip file. The converter provides you the exploded view of this, and here we'll see the AppX manifest file and all of the binaries that are associated with this application. I'll bring up the manifest here and show you that this is the tag for the identity. You can see version 1.0, my publisher, and the name of the application. And then the other key capabilities on this is that it runs full trust. Right? So all these applications have full access to the Windows and the platform. And through this, now you know your application's running on the desktop bridge. A couple other important files to call out. There's a file here called registry.dat. That contains all the changes to the registry when the installer was running. And secondly, the VFS folder. This contains all the changes to the file system when the installer was running that are not associated with the install location of the application. And so that way, if an app is actually writing to System32 during install time, it can still, at install time, think it's writing to System32 and read from it, because the file system is merged at runtime. The OS and the local copy is merged at runtime for both the registry and the file system. So the app doesn't know that it's not actually reading from the system or launching a DLL from the system that's actually been redirected. So one thing about AppX packages, they don't load unless they've been signed with a certificate. So I'm going to install the certificate that was created by the desktop app converter. It's a temporary cert. And this is just a simple call to certutil. We'll see it's added to my Trusted People store. And now I should be able to click on the AppX file and bring up the app installer. You'll see that the converter also created image assets, which are based on the icon of the executable. And so you'll have multiple image assets for different resolutions and scale factors on the device. And when I run, I'll click Install. The app will be installed and it'll launch. And what I've got here is the full Notepad++ running on this machine essentially inside of a container with the file system and registry redirected.
Do people think this is kind of cool? He installed an app, did not touch the file system, did not touch the registry. He can remove it and the machine is back to the way it was before. You don't have to worry about all the stuff left behind. I mean, this to me is modernization of your existing apps. And he started with an MSI, so he didn't have to even go build a new installer. He was able to take an installer he already had and just wrap it.
Yep. And
sorry, how would you actually deploy that to people? Like, I know you can put it in the Windows Store, but if it's something just for our company, how would I get it out to people? Would I have to email it to them, or is it our own internal store? Or?
So you're stealing my thunder, but yes, the next slide, the question is, how do they get deployed? AppX packages on Windows 10 can be deployed through all of your typical standard Intune, SCCM, HTTP, and even file shares. And you'll notice here I just double-clicked on the AppX file so you could copy it around.
You want the slides or you want the...
Oh, no, stay here.
Dan, you?
Go back. Or go back to my, yeah. And so I was just going to show you Scott's point. The user's in control here, so you can the user can uninstall, and the app is cleanly uninstalled from the system.
Awesome.
Really, because the AppX package is a zip file, the installation process is unzip. That location is read-only, and then when you uninstall, it's just deleted from the user's system. So that's a scenario where you do not have the source for the app. Let's go back to our eShop app and figure out, okay, I've got the source for that. How do I deploy my eShop app? Did not go? Oh, oops, I picked the wrong one. There we go. And so here what you'll see is I'm back on my eShop application. I got my WinForms app. And Visual Studio has introduced a new project in Visual Studio 2017 Update 4. It's currently in preview mode.
Shipping the first or second week of October.
And what they've added is what's called a Windows Application Packaging Project. So if I right-click on my solution, not the project, and choose Add, New Project, and if I click Windows Universal, I'll see a new Windows Application Packaging Project. From here, I'll just call this, eShop WinForms App. I will target, let's see here, just the current public release. I got a mouse, I should use it. And what it's doing now is creating a packaging project that will take the output of my Windows Forms application and package it into an AppX file. If I look at what Visual Studio has created for me, it's created my manifest. I showed you the details of that on the previous demo. It's created a temporary cert for me. And then it's got this interesting applications node. It's also got some default assets. I'll get back to those in a second. The applications node is asking me, which application do I want to package? Because you can have multiple front ends to your app. If I choose the WinForms app, now the packaging solution has a reference to that application. Uh-oh. Oh, .NET Core 5. Scott, I blame this on you. We'll have to see what happens there. That didn't happen in the dry run. But you can see it still has a reference to the eShop WinForms application. In the manifest, I can bring this up. Sorry. Let me back up. Back on the assets. These are default assets, and they typically tend to be pretty ugly, the big square. Nobody likes that. So I'll show you how to regenerate those. Visual Studio, when you bring up the application manifest, it has a Visual Assets tab. And there's a new tool called the Asset Generator. If I point my source at my demo, I have a new PNG file that I'll use. It's essentially, it looks a little like a shopping bag with a lot of transparency. And I'll click Generate. And it's telling me that it's going to overwrite the existing default options. And you'll see now that it's generated all kinds of assets for me at different scale factors so that the assets look correct when my app is scaled to either 100% or I have something up to 200 or 400%. The other thing usually you do in an enterprise is you don't use a temporary cert. I'm going to delete this cert, and I'm going to bring up the packaging tab and choose my certificate that I use in my enterprise. So if I choose certificate, select from file, and I go back to my documents demo, and choose my Ignite certificate. I've already trusted this in my enterprise, and so when I rebuild, it'll insert the publisher identity into the manifest for me. If I save this, now I should be able to do two things. That's all initial setup time. Now I should be able to do two things. I should be able to hit F5 and be able to run it as a packaged app, and I can also build packages from the Visual Studio menu. So if I set the package as my startup app, and deploy, And now it's running F5 debugging for my packaged application. Now, if you want to build Apex packages that you can deploy yourself, you right-click on the package, the Windows Form application packaging project, and go to the Store menu and choose Create App Package. In this case, I'm not going to upload to the store, so I'll choose No, Next, and then I can choose version numbers and which architecture to build. I'll go ahead and create this. And it'll take a moment to take the output from the Windows Forms application and package that up, all the content up. While that is doing that, I will show you that in the Start menu, when I pressed F5, the application was actually deployed on the system. In order to demo installing the Apex package, I'll need to uninstall this F5 app. I also could have incremented the version number of the Apex package. All right, so building my package is done. If I click the link, I'll bring up File Explorer. And you've got all the tools here for command line installation with PowerShell. Since I've already installed the certificate on this machine, I can simply double-click the Apex bundle and choose Install. And now my Windows Forms client application is running as an Apex package. So let's see here. Let's go back to the slides.
That's pretty cool stuff as well. If you could do this with earlier versions of Visual Studio, but it required going to command line and doing a lot of command line stuff. And now it's built in the IDE. Right-click, add to project, associate, and you're good to go. So it's really simple now.
Yep. So to summarize, the question is, because I have the source code, do I add extra metadata? Not really. It's mostly the identity is the key to the manifest file, and the capabilities and the full trust capability. There's other things. Let me summarize here, and I'll get to it in 1 second. The main thing is that it provides you a simple, trusted, and clean install and uninstall experience with the Apex packaging, because of the virtual file system and virtual registry. The other key point is that anything that you interact with the system or the shell is declared in the manifest. I didn't have time to go into that, but if you want to register a file type association or protocol handler or one of those two, you do that in the manifest, and so the OS takes care of adding that capability to the package versus third-party code. With this scenario, you don't have third-party code running during install time, which can mess up your machine. The other thing I mentioned, the app now has identities, so the OS can manage it, as well as you can call new UWP APIs. An example might be adding toasts or notifications that certain background processes have been done, and that'll work on Windows 10. A couple of things to remember. This is technically not a sandbox. It's just a lightweight redirection of the file system. So you can call any API you want, and technically a malicious app could figure out ways to shell execute and break out of the container and do malicious things. And lastly, there are a few limitations. You cannot install drivers and you cannot install services with this technology. And we don't allow you to auto-elevate. There's no support for auto-elevating as admin. In terms of conversion, we talked about two areas. One is if you do not have the source code, you can use the desktop app converter. If you do have the source code, then you'll want to use the Visual Studio Windows Application Packaging project. And thirdly, I want to call out, we've been working with a lot of setup providers in the industry leaders there, in terms of adding support for both MSI and their Apex packaging. That allows you to maintain one setup source base and build MSI for your down-level Windows 7 clients, as well as Apex packages for your Windows 10 clients.
Cool stuff?
Very cool. Yeah, so as Taylor said earlier, I'm Scott, and I'm from the .NET team. And I want to talk about the next step you might go in this process is, hey, we've done the high DPI support for our WinForms application. We've repackaged our applications so they're easy to install and uninstall without hurting the machine. The next thing might be that you want to modernize your middle tier. We showed this project earlier. It was a WCF middle tier. And, most of us, I think in the long run, most folks will want to journey to either containers on premise or maybe containers in the cloud. So my team has actually put together a whole site. You can go to dot.net/architecture, and we have a bunch of ebooks that we've actually built on containerized building microservices and containers, and also some of the stuff we're talking about today of being able to take an app and kind of modernize it. This slide kind of shows all the books that we have up there right now. And you can see one we just added this week at Ignite was Modernizing Existing .NET Applications, which goes through some of this process of taking things like a WCF backend and going through the process of wrapping that up in a container and putting that in the cloud and a variety of things. So I'm going to quickly go through some of this stuff, but I really recommend grabbing the book or going to the site and grabbing the book, and you can get a real detailed drill into this. And, so the next thing is containers. We kind of talked about containers for the desktop. Why are containers awesome? Containers are awesome to me. I don't have to change my app a lot. Your existing application, whether it's a .NET Framework application, a .NET Core application, can just run in containers. The real thing here is, when it comes to containers, is it's a great mechanism for deploying applications. Today, in my world, we have a variety of ways of deploying applications to servers. If you have a back end, we have MS Deploy for doing a publish that way. You can FTP. We have a mechanism where you can share a file share and copy stuff. That's all kind of all over the place. This gives us one consistent unit that you can use to publish these things. At the same time, once you actually have your app containerized and running in container backend, it also means that your DevOps people can DevOps everything the same way. They don't have to have, hey, I've got a hand-built virtual machine here. I've got some other thing that I went and specially copied stuff into over here. Really, it's a unit of containment that can be pushed around to servers, making it easier to scale up and scale down. And we have technology in Azure around Azure Container Services and Service Fabric. These are both two places that you can actually host these things in Azure today. I thought I was on this slide already. Anyways, the other thing about Docker containers that are awesome as well, me as a developer, one of the things I've always struggled with is I'm building on my machine. My machine might be a Windows 10 machine, but I'm deploying to a Windows 2016 server, or I'm deploying to Windows 2012 server, and that server and my machine might not be at the same patch level, and so the app could behave a little differently. One of the cool things about containers is I can actually develop on the exact same image that I'm going to run in production, which means it's going to take some of those errors away. Another cool thing about containers, especially for local development, who in here has installed a SQL Server on their local dev box? Who has uninstalled one and hoped that it actually came off the box right? Yeah. So as I show this application, I can actually have my containers depend on other containers. And things we have is we have things like SQL Server already packaged up in Docker Hub in containers for you. That means on my dev box, I can actually build an app, give that app to Taylor on his machine. He might not have SQL Server installed. It will actually bring down the SQL Server container on his machine, run the app using that container. When he's done, if he wants to, he just deletes the container. There's nothing on the file system. There's nothing anywhere. So it really makes the developer process easier. This is a very simplified version of this. I've got some URLs here you can check out afterwards. But really, all I've got to do is take any of my existing .NET applications. And we do this for .NET Framework and .NET Core. You can right-click and add Docker support. And that'll add some compose files and a Docker file to your application. At that point, you can decide to run that compose file, which means when you control F5 and F5 locally, you're actually running the app in that container. Or if you want to run the app on your local machine outside the container, you can set your app back as the default choice. And then we have a variety of mechanisms to deploy these things to the cloud. One is I can right-click on the application and publish it to App Service. App Service has support for containers. And we have support for running containers in Azure virtual machines. I've got a link here. It'll take you to some steps in the ebook that will actually show you how to set up CI/CD. So as you develop and save, your code gets built in the cloud and deployed to a container running in a virtual machine. And we have the same thing for a container running in Azure Container Services. So it's really easy to build and push these things around. With the same update to Visual Studio that Adam was talking about, we have the ability for you now to take your apps and publish them to a container registry. And that allows you could have your own local container registry for your organization if you're running containers locally. Or you could push to the Azure Container Registry if you want to use one of our container hosts. Or you could push even to something like Docker Hub if you want to publish it to somebody else. So we have a variety of ways, once you containerize your application, of pushing it around. So let me jump in here, and I will show some of this really quick. Good. So I've got that same app that Adam was showing earlier. Close a few of these windows out. And this is a WCF service. So another thing people always ask me is, hey, I just shipped .NET Core 2.0 a few weeks ago. Should I move all my stuff to .NET Core 2.0? No. If you have working code with WCF, or working code with ASP.NET MVC, or working code with ASP.NET Web API, you're not going to gain a lot of benefits just by porting your code over. So I really recommend just taking your existing code, continuing to maintain it, like Taylor said earlier in the slides, and now we just have better ways of publishing and hosting it. So I'm going to take this WCF app that Adam was running against earlier, and I'm just going to do what I was just describing. It's a WCF app. I'm going to right-click on it, and I'm going to add Docker support. So this is going to add some Docker Compose files, but more importantly, this is my Docker file. And this is where containers get really interesting. This describes what my app runs in. So we have an image of Windows Server up in Docker Hub right now, and that's where this Microsoft/ASP.NET:4.6.2 comes from. This means we have a Windows Server container in Docker Hub running .NET 4.6.2. Now, what I've done here is this is where I'm going to show some really cool stuff. This app needs a database, and it needs me to configure that server. This is stuff I want to tool in future versions of Visual Studio. So what I'm going to do here is I'm just going to paste in some additional commands here. Notice this. What I did here is I said run, add Windows feature web server. And then I said add support for WCF TCP and WCF HTTP and WebSockets. So traditionally, if you're building a virtual machine, you probably would actually boot up a virtual machine. You would RDP into that thing, install all of this stuff, and when you're done, you would save it and say, I've got a great virtual machine. In a text file, I just said, take a base Windows Server image, add a bunch of features, and call it good.
The other thing that would happen is you'd do all that stuff through the UI, and you'd go on vacation, and that server would die, and someone else would have to come in and figure out what steps you went through to get that application up and running.
Yes.
And I've been that person, and that's a terrible place to be.
It is terrible. I've been the same person before, especially when you find somebody went and copied something into System32 or whatever.
Yep.
So now in a text file, I can describe my entire environment. So that's pretty cool. The next thing is there's this file called a compose file. And this is right now saying, here's my service. I've got this eShop WCF service. It gives the name of my image and the Docker file that makes the image. Now, what's cool about this is I can actually add to this as well, and I can add dependencies. So over here, I can go and say, copy this over here. Now, what this says is my app depends on SQL data. And SQL data is another image. And notice that for SQL data, which I've defined here in my list of images, it's got a pointer to Microsoft/MS SQL Server Windows Developer. That's another container image running up in Docker Hub, or in Docker Hub, available for download. And so what this means is when I control F5 or F5 this project, the first time, it would grab that ASP.NET Docker container and pull it down on my local machine. It'll grab the SQL Server container image, pull it down on my local machine, and then I can just Control F5, and it's basically installed that in a single file, though, not in a, no MSIs are running, it's not touching my registry or anything. When I'm done, I can just nuke the image, and I'm good. So we save this, and let's just run this.
And while he's running that, the other kind of nice thing is that we update all those images every month. So every month, Patch Tuesday comes around. Someone in our servicing team, as they're publishing the Windows Update to Windows Update, publishes a new container image to the Docker Hub, one for every version of Windows we have up there. And then automatically in the background, the ASP.NET image gets built on top of that, and the SQL image gets built on top of that. So when you pull down an image from the Docker Hub on Patch Tuesday, usually an hour or so after Patch Tuesday, maybe 2 hours, you're getting a patched image. You're getting the image that's fully patched from the start.
Yeah, this will actually take about a minute the first time I'm running this, because this is doing what I just described. It's actually installing a SQL server. It's installing a Windows server on my machine. The cool thing is once I warm this up, your Control F5 experience is going to be pretty good. And I actually took this a step further. I actually ran the debugger, which I should not have done. So it's actually going to boot the debugger up as well. But this shows that not only can I run these containers and build these containers locally, I can actually debug into them just like I did a local app. Now all I've got to do here is click the catalog service. That's the service that we built. This is the IP address and URL of my service running in the container. I can go back to Adam's client app here. Inside of here, he's going to have a config file. I don't want that one, actually. What file do I want?
The manifest?
No, I want the one that has the URL in it. Maybe it is this one.
Oh, it's down the bottom, yeah.
Yeah, there it is. And I'm going to uncomment the local host, and I'm going to put my container in place of it. So let's comment that out. Let's comment this one in. And I will now paste that URL that I just grabbed there. Stick it right here. There we go. Let's just verify that. And I can automate this, but I wanted to show you the raw steps, just so you could see the mechanics behind how this actually works. And I can start an instance of the WinForm application. And now it'll actually be talking to a Windows Server container running. There it is. All this data came through, running a Windows Server container on my local machine, and running a SQL Server in a container on my local machine. And I could even show that.
You got to be an admin.
What?
You have to run as admin.
Do I?
Yeah. Oh, at least to start when you have to. Yeah.
And so if you look here, I ran a command showing what processes are running in Docker, and you can see I've got my service, and I've got my SQL Server. And when I'm done, I can actually run, there's another command here called Docker images. And that's going to show my service, my SQL Server, all there, and I can delete these and remove them anytime I want, but that's how easy it is to go install all that. So once I've done this, I give Taylor my app, and he doesn't have to install SQL Server or Windows Server 2016. It all just comes down as part of the app. I'm not going to show it, but if I go back to the slides, I did talk about we have 2 links in the slides that talk about how you would actually deploy this in Azure Virtual Machines or Azure Container Services, and it just runs. The next thing we talk about is, great, so I've got my WCF app running up in a container in Azure or on-premise, and the next thing I want to do is I'm going to build something new. So since we shipped WCF, the world's changed quite a bit. I mean, we all have, I guarantee you everybody in the room has some kind of device, whether it's a phone or a tablet, or there's a web app somewhere. And we find that the stuff that we build for our WinForm application, we want to expose it in a way that it's accessible by anybody. And so some of our newer tech, like ASP.NET Web API, is a great way of doing that. So I'm going to quickly show how you can take an ASP.NET Web API, which I would actually call a microservice. If you actually make it just do one thing, it's technically a microservice. You can build one of these, and we have tools in Visual Studio then that will actually take that REST endpoint that we built and they will wrap it up into a class library that you can then share with a Xamarin application, a WPF application, a WinForm application, a UWP application, or even an ASP.NET application. So it makes it easy to build an API and then share that a library so you can call it from any of the texts that we have at Microsoft in your system. So here's the basic steps here. Is you're going to create a core API. You're going to add this cool package called Swashbuckle. And what Swashbuckle does, if you're familiar with WCF, you're probably used to WSDL and some of the stuff that we actually describe the APIs. It adds a WSDL type feature to an ASP.NET Core application. I can then download that Swagger file. That's a description file that describes the API. And then we have a feature in Visual Studio where I can right-click and add a REST API, point it to that file, and we'll build you that class library, which you can then share to wherever you want to. So let me try to show that real quick. So I'll create a new VS.
You got to switch over.
Thank you. Okay. So let me create a new VS. And I'll show how simple this is. So I'm just going to do File New, Project, and I will select Web, and I'll select an ASP.NET Core application, and Web Application 1's fine. We can call it whatever. And we have a variety of project types here. One is a Web API, technically what I would call a microservice. And I'm going to select OK here. You might notice that for these apps, we even have, for new projects you're building, we have the ability to add Docker support right in the IDE. So I can right-click and do that add, but as I'm doing a new project, I can click this, and I can select between a Windows or a Linux container, whatever my choice is. So I'll create the API here. And this is just an API. It's got a default test API in it called values. You would obviously replace this with your own API. In fact, what I would do is I would probably go and take an API. We did this before the talk. Me and my team were taking APIs from the WCF app and basically just copying the code and pasting it into Web API. It really is that simple to get it to work. So let's go add this support for Swagger. So I'll go and manage NuGet packages. And we'll go to Browse. And there it is for me, swashbuckle.asp.NET Core. That's the package that I want. Let me go find the right one. There's too many here. There it was. So I'll install that. And so the big thing here is ASP.NET is by default just provides support for HTTP endpoints. It doesn't actually do metadata or stuff like that. We're an open source technology, and when there's already great solutions in open source, we don't recreate those things. And so there's a variety of these things like Swashbuckle out there that actually can enhance our projects. And so I don't need to build one because there's a great one out there in open source. Once I do that, I have to do a few things to configure it, and I'll show you kind of some of the cool functionality you get out of this. So I'm into my ASP.NET Core startup project, and I need to add a few things here. I need to add so this adds a line to my services. I say I want to use MVC in this, and I've added Swagger to this. And so this is saying, build me a Swagger file. We'll have it called V1, and we'll give a title, the name. I can name my API, and I can put a version of my API. I need to bring a using statement in here. There we go. So that actually wires that up into the dependency injection pipeline in ASP.NET Core. I've got to do one more thing here, and I have to add support for this down here. So I'll say use Swagger. And now if I run this app, it's an API app, so it's not exactly what I would call cool to watch. I don't know which way we have the function lock on, so I'll just do this manually. This will launch a browser, and I'll be able to go to an endpoint. It's a values controller, not very, very exciting. This should bring up a bunch of metadata. Not super exciting, but I can take this metadata and feed it through other generators to actually generate client code. So let's actually save that. I'm going to use that in a second. And I'll overwrite the one that I've already got here. There we go. I want to show one more cool feature of the swashbuckle. That seeing that raw URL, I mean that raw data is not very exciting. But I can also come down here and add one more thing. I've got a snippet of code here. It says use Swagger UI. It gives it that same endpoint that has the Swagger metadata. And what this does is this gives you basically a test platform to call your APIs. So if I run this app again, now I can go to back Swagger. And this tech is actually can be used inside of your organization for people building apps. I can go to back Swagger, and now I get a full UI experience. If I had multiple versions of the API, I could drop this down and show those. If I want to go test the API, I can click these buttons. It'll show me examples of what the input would be like. I can tell it what return types I'd want to have. I can call the API. It'll show me how to call the API from CLI. It'll show me what the URL would look like. It shows me the values, all the response headers, so I can test my API, my microservice, live in the browser right here. The final step that I want to do here is I'll go back to my solution. I'm going to right-click. I'm going to add a new project. And I'm going to add a class library. And we're going to call this my API. And then what I'm going to do is I'm going to take that class library. This is a new feature we have in Visual Studio. I can go over here and say add REST API client. If I had an API that I'd published to Azure, I could just point it to my one in Azure. Or I can click this button here, click to use a local file. Let's go to downloads. Let's grab that JSON that we just created, press OK. And now we're generating a client for you on the fly. And once I have this client generated, I can share this code with every app type we have in Visual Studio to make this API callable from your apps. So that's done. And you're going to notice up here, I've got my client, I've got my interface, and I'll just briefly show that if I look at that interface, you're going to see all the methods. Here's the API values get with HTTP messages, API values post, API values by ID. Basically, it creates interfaces and code for every one of the things that I have in my API. I share this project. You can call it from any app. So with that, I'm going to turn it back over to Taylor and let him talk about how you take your SQL and modernize it.
Yeah, thank you. So a couple things just to kind of build on what Scott said. And with Windows Server version 1709 and Windows 10 1709, or the Creators Update 2, we made that F5 experience in Visual Studio quite a bit faster. It's still not where it needs to be. It's still not as fast as I want it to be with containers. But we shaved off, I think, 20 or 30 seconds on that inner loop build time. We're working on shaving that off even more for the spring release. So we'll be doubling down on that even further.
Yeah, I think we want to get to a point where you can develop in a container as fast as you could develop outside a container. That's really the goals of I think both of our teams. This is the future style of development we think is going to happen, and we need to make it first class.
Yep. And then also, when he was showing the ability to choose between Windows and Linux containers, one of the cool things we've done is we've added native Linux container support to Windows 10 and Windows Server. So we actually do that by downloading and running an optimized virtual machine with a Linux kernel, either Canonical or Docker, soon Red Hat and SUSE as well, just completely natively. So we're making that Linux, Windows parity or experience between the two quite a bit easier. So a couple cool things to play around with. So we talk about modernizing the back end. I kind of have to start with some of my history. About 15, 16 years ago, I worked on the Microsoft smartwatch. a little before its time. But it was a really fun project, except my job basically ended up being reinstalling SQL. Like our default install for development was 4 physical machines under a desk. 2 of them were SQL servers, and 2 of them were web servers and service servers. And we had this custom little replication thing we had, and there was a weird setting you had to change in the SQL install, and nothing cleaned up properly. And so, about once a week, you had to come in and like completely reinstall the 2 SQL servers. And inevitably, I would go through one of them and hit the right setting, and another one I wouldn't. Then I'd have to uninstall SQL and start all over again, and it was Tuesday. I pretty much swore to myself that I would never reinstall SQL again. And when we got to containers and I could just do a Docker pull of SQL, I will never install SQL again. Like, I won't do it. I won't even do it for a demo. But I will talk about how you can go about using that installed SQL that you have and bringing it into a container. And I'll talk about a couple of the reasons you might want to do it. So a couple things to think about as you're modernizing applications. For your existing data that's already in SQL, keep it in SQL. Unless you've got a really good reason to move it, don't just move stuff for the sake of moving it, right? But we can make SQL a lot easier to manage by either putting it into a container or putting it into a cloud service. The other advantage we get out of that is we can make the data accessible. So we think about mobile companion applications. An example I use a lot is you think about something like QuickBooks. If you've ever watched an accountant use QuickBooks, like they fly through that application. And it's not a particularly pretty application. It's not like the app that you're like, oh yeah, that UI is gorgeous, but they're so productive with it. And it's certainly not the app that you really want your CEO and CIO and CFO looking at on a day-to-day basis. They want to see a nice, pretty graph, and they want to see it on their iPhone or their iPad or their Android or whatever it is. We call that a mobile companion. We can get to that point when we have the data and the endpoints accessible to those devices. So we do want to start to think about how do we move some of this data to be accessible in the cloud or across different devices, right? Now for our new data, for the data that we're building for new applications, you should use the best tool for the job. That often is not SQL. We have blob stores for large images. We have data lake. We have table stores. We have all sorts of different ways to store data, Redis caches. Many of those services are going to benefit from using different types of data storage. So think about that as you're building those new pieces of code. What is the best way for me to store this data? Maybe it's SQL, and maybe it's not. And then let that service own its own data. If that service can own its own data, and you can build additional services that may replicate or sync between those, you're going to increase your reliability, and you're certainly going to increase your scalability. You're going to get closer to being able to have linear scalability, which is something we really have had a hard time doing with the traditional SQL model. The company gets bigger, we can add more processors to SQL, we can add more memory to it, but eventually we hit a curve, and we have to start splitting up the database, and that becomes difficult to do. So let's talk about a couple paradigms for this. Image to Docker is a PowerShell module. It's open source. I'll have a link to it in a minute. One of the things it can do is it can make a container out of an existing database. So we can take our database, we run image to Docker, and it's got a command called convert to Dockerfile. Convert to Dockerfile can take a remote path, and an output directory, and the type of artifact we're talking about. There's some other parameters you can pass to this as well, like which databases and all sorts of things. Or I could use it for IIS web servers or a number of other artifacts. But at the end of the day, what it's really going to create is it's going to create a Docker file, like what we showed earlier, which says, from Microsoft SQL Server, blah, blah, blah. And it's going to have a couple of our database files, like the MDF and LDF files, right? That are going to be referenced by that Docker file. So when we build it, we get a container that has our database in it. Why is this useful? Well, for your development teams, or as a developer, I now have a copy of the data that's in production. That's pretty handy for testing. Now, a lot of times we'll go through and sanitize that, so that's a really common process. We might take that container, run some additional SQL scripts against it to remove PII or data that we don't want every developer in the environment to have. But now the developers, when they hit F5 and that app opens up, they're running with the exact same database, same schema, same version, same everything that's in production. That will reduce errors. It will reduce the times when you go, oh, oops, we got it into production and didn't realize that some of the values had special characters in them, and no one handled that, an exception, and now our site's down, right? The other thing you can do is you can run this container in Azure now, right? You can just move it into Azure. So here's a pointer to image to Docker. Again, it's open source. Contributions are great. There's definitely areas that it can be improved on. So yeah, question? So what kind of impact is it going to have against a production live database? It is read-only, so it's not accessing the actual database. It is certainly going to have some impact on I/O as it's copying things off of that database, for sure. My recommendation with all things in operations is test it first before you go start mucking with production. But I've been using this for a few projects that I've been playing with, and we've got a couple customers who've been using it pretty successfully as well. Another option is always to run it against a backup. So yeah, go ahead and grab that, play around with it, submit issues, submit feedback to it. Docker contributes to this project. We've been contributing to it. We've got some MVPs contributing to it. It's a pretty useful tool. The other option is really to migrate it to the cloud. And I'm not going to go into a whole how to migrate databases to the cloud. I think there's like 7 sessions here about that. I will give you some pointers to a few places to go. So for SQL Azure, they've got about 4 different ways that they show to migrate data, anywhere from website or SQL server goes down all the way through keeping it up the entire time. Right? This will migrate it to a PaaS service. The value of the PaaS service, you don't have to manage it anymore. You let us do it. The disadvantage is your data is in Azure and you're using and you're dependent on Azure. And for some people, that's not okay. For others, that's great. For me, that's great. I work for Microsoft. Makes sense for our data to be managed by us. The other option is to run a VM. Why would I run a VM? Well, I may not quite trust the container to do everything yet. Or maybe I'm using SQL reporting services or features that aren't containerized yet. I can just pick that VM, move it into Azure. I also retain the portability to move it somewhere else if I want to. Right? If tomorrow I'm like, you know what? That other cloud down the street is a better cloud. I'm going to go over there. You can do that. Right? I'm happy if people are using our technology, whether they're using all of it or some of it. I'm happy if they're using just the right pieces for the job. So that's a quick summary of, or quick view through an application. So we went from our front end, we talked about the middle tier, we talked about the database. We've got some pointers to various pieces throughout the deck, some additional sessions that you guys should look at checking out. I've got a whole list of, oh yeah, please evaluate our session. We all did a great job, right? Yes. I'm going to go back to the very beginning, the faster way, because it has 2 important links on it. And then we'll take some questions too. We got a lot of slides. Probably. All right, there we go. So the slides are available already. If you want to grab them, they'll also be published along with the session. And then our email addresses for feedback, thoughts today, tomorrow, next week, next year. So.
Yeah. We have WCF services, but they are federated SOAP services. Does this process work with federated SOAP, or do I need to convert to REST before containerizing?
Nothing requires, this tech is just moving from running on a local machine to a container. It does not require you to change the file formats or the wire formats or anything at all. Everything should work. Yeah. The only limitations we have today, which maybe you want to go into, the Active Directory limitations?
Yeah, so we do have Active Directory support for containers, but there are some challenges there. You have to use group managed service accounts to give the container an identity. So there are some caveats around that just to be aware of.
And the second question is the size of the image. So it sounds like you're downloading a full Windows image. So is the container size essentially the same size as a VM?
It's not as big as a VM, and it's gotten smaller in 1709. It is about 10 gig for the base container image of Server 2016. We've halved that in 1709. We're working on getting it even smaller for spring and then next fall. So we're on a journey there.
Thank you very much.
We use a lot of Windows services for back-end processing.
Yeah.
Can you modernize those by putting them in Docker containers?
Absolutely. Yep, you can run Windows services. They'll run just fine. You can just install them and run them in the normal way. The one thing that I found most people find benefit to doing is to remove them out of a service and just make them a console app, so a fairly small change to make. The value in that is that you can just write to the console then as opposed to writing to logs, and so all the tools and everything pick it up, but completely up to you.
Does Docker have any, or can you monitor the Docker container to see whether that process died or anything like that?
Yeah, that's the other, so there's two models to look at. If you look at actually the Docker files for IIS and ASP.NET, we have a tool that we publish called Service Monitor. Service Monitor basically just watches for a service to be alive, and if it dies, it exits the container, which kind of makes it approximate the normal kind of console method.
Okay.
Yeah.
Thank you.
I assume for WinForms and other non.NET Core apps, if you're using Docker support, it's just targeting Windows containers, not Linux containers?
We have Windows and Linux container.
Okay, so there is Linux container support.
No, for WinForms applications.
Oh, for WinForms applications.
WinForms applications will be on Windows containers.
Yeah.
Yes.
I know .NET Core, you can
Yeah.
target Linux.
For .NET Framework applications, we'll target Windows containers only, and .NET Core will target both
Right.
every kind of container we have.
Anything cool.
Yeah.
Any guidance on when to, if you're taking an existing web front end or even an API, when would you choose a container rather than just deploying it against an app serve, web app, or API?
I mean, I always try to go up the stack as far as I can. So if there's a PaaS service that meets my needs, I use it. If I need the portability of multi-cloud and there's not an equivalent PaaS service that's easy to tool against in both clouds,
Right.
container makes good sense. If there's not a PaaS service that meets that requirement, container makes good sense. But like SQL is a really good example of that.
Right.
If I'm in the cloud, I'm going to use SQL, Azure SQL, because there's just no reason for me to stand up my own SQL container if I don't need to.
You might be on your own SQL container because there are a few features that Azure SQL doesn't actually have. It
Right.
doesn't support the agent running on the machine for obvious reasons. It's a PaaS service.
Probably get
But
functions to do that.
I follow up what Taylor says. Move as far into PaaS as you can. So my team, we took the ASP.NET website, which was a series of about 12 VMs, and we moved those VMs from a different cloud provider to Azure a couple of years ago. And then over the next year, after we did that first lift and shift kind of move, we then moved the parts we could to Azure App Service and to Azure SQL. And the benefit we got out of that was obviously I don't have to do backups on those things anymore because the PaaS service is doing it for me. The reliability uptime is done by the PaaS service, and the patching is done by the PaaS service. So I echo what you say is take as much to PaaS as you can. Containers give you more control. So it's always a control spectrum.
Right.
Less control, more we manage it for you. But the cool thing is we offer the whole spectrum.
I assume your Swagger support's being revved for OpenAPI 3.
Yes.
And nice to see the auto-gen from the web API to Swagger. Are you guys using AutoRest to do the other way around?
We're using AutoRest to do the other way around, yes.
Perfect. Thanks.
You're welcome.
Is AppX supposed to be the natural predecessor for desktop applications to MSIs?
Yeah. Yep.
Yes, it's the new model for Windows 10.
Okay.
We've actually been kicking around even calling it something different to get it a little closer to that naming, but that's really the way to think about it.
Okay. All right. Great. Thank you.
So with using the desktop bridge to take an existing WinForms app, you said the install directory is read-only, so that means it cannot update itself?
Oh, well, how updates work is the app is actually uninstalled and then the new update is installed on top of it.
Okay.
And that's actually one of the cool
It means
things
it
that you
wouldn't
get.
work for us because our app actually updates single files at times and not necessarily the entire.
Well, one feature I didn't get into, and some of their talks go into a lot more details, but the AppX packaging does support Delta updates. So if you only update one DLL in your package and you ship that, through the store and through other mechanisms, the Delta updates will just update that one file.
Okay, thanks.
But it will be a new version of the package.
For the Docker support, when using the endpoint, can I use the external proxies which I'm going to use into the WCF services itself? So all these external proxies that I'm using for WCF services, can I use those all endpoints as binding into the Docker?
Yeah,
Yeah,
yeah.
yeah,
Okay.
works just like it always would.
Okay.
Yeah.
Thank you. Thanks.
You're welcome.
Great talk, guys, first of all. I just had another question around like the updates for the AppX files and whatnot. So I assume our application would automatically update itself if we put it in the store. But
Yes.
I think you said like we could also just deploy it on like a regular like file share or network share or something like that.
Right.
Would it auto update itself then, or?
As of right now, today, there is not auto update from a file share or HTTP. That is something they're looking to build in the future release.
Okay. Is it possible to make our own internal enterprise store if we wanted to?
Yeah, that's another area I didn't get to, but there is the Microsoft Store for Business, where enterprises can sign up and have their own store, publish their own apps there, and then all the updates are auto-deployed to your machines.
Awesome. Thank you.
Just one other question on .NET 4.7. I've been hearing that a lot of energy is being put into .NET Core and less in .NET. So with a port lift and shift, and you're still on WCF, do you see your strategy maybe changing where the .NET base framework is still going to be more fully enriched and supported, at least for the next year?
.NET 4.7 will never, ever go away. And in fact, the way we're going to rev .NET moving forward is we've been talking about something called .NET Standard, which is a series of APIs that are consistent across all the .NETs. What you're going to see is, as we add a new API, whether that's in .NET Framework or .NET Core, that will eventually get into .NET Standard, which means it'll be on all the .NETs. So the way we want to look at .NET moving forward is we don't just invest in Core and ignore Xamarin or invest in full framework. And we want them all to grow at the same time, and we want them to be consistent. Obviously, it can't be 100% consistent because obviously Core runs on Linux, which means it can't do the Windows-only stuff. But you'll see us continue to invest to make sure that WCF has latest security features, the latest web features. We'll make sure WinForms and WPF both scale well on new monitors, and we make sure that everybody gets the brand new APIs across the board.
That's
Does
great.
that help?
Yes. Thank you. That's great.